Now this only goes between 0 degrees and 180 degrees, so not going to be the most useful motor in the world, but it's a good starting point. Now, just as a quick head note, now most of this stuff that I'm showing you guys, some of it I have worked out myself. Some of it I did get online. So I will, when I get my website up and running, I will be posting links to every single thing I find. And look in the description of these videos as well. Descriptions will have the links to those websites. So this is a servo motor, and I'll make this rotate from 0 to 180 degrees and from 180 down back to 0. So here I am in my document, and the only two components I have in this one are the Raspberry Pi Pico. Again, we know why we need that. Our servo motor, we can turn from 0 to 180. Now we can use this for quite a few things. We can use this to, I don't know, open blinds in a room, because blinds don't need to go all the way around in some cases. We can use this to open a door. We can do so many things with this. Whatever function you think a motor needs to do, and if you can divide that full rotation by half and still have somewhat of a functional device, you can use a servo motor. Now, there are some servo motors that can go 360, but we don't care about that for now. We're only going to focus on the one that goes between 0, well, from 0 to 180. So here's my block diagram. I have no input device, but I could set an input device to control this, but I don't have one as it stands now. The Raspberry Pi is going to be my processing device. And for output, I'm going to have only this servo motor. I might do LED as well at some point, but for now, just the servo motor. Pseudocode says start, and I use repeat forever because this is going to be a while loop, and I just wanted to go output, rotate the motor from 0 to 180 degrees, sleep for half a second. I'm going to come back and say rotate the motor from 180 degrees to 0 degrees, sleep half a second. So what this should do is just move it from 0 to 180 and bring it back from 180 to 0, and that's it. Stop my program. So that's why I have end there. Below that, I have my flowchart. And again, more or less the same thing. Start my program here. This is going to be an output, so I move from 0 to 180. I put this as a process because you pause, but nothing actually is shown on screen. There's just a pause in the program, so the program knows to wait. Then I go on and I say move from 180 to 0. I do another process that pauses for 0.5 seconds, and notice this arrow going back into that very first one that says move from 0 to 180. Because this is an infinite loop, it's going to keep going around and around and around, and it will never stop unless I lose power on my laptop, unless the Raspberry Pi burns out, unless the servo motor burns out, unless something happens to stop it. But it will never stop if conditions are okay. That's why while true works for this. And then I have my end thing there. Next, on my circuit diagram, I simply have one pin going all the way up to the positive, one going down to ground, and this other one should have been connected to the Raspberry Pi Pico, but let me just ignore that non-pin connection for now. Let me actually open, if I can find it, the circuit diagram for this. I might as well show everything. I'm pretty sure I have it connected somewhere. So let's see if that opens up. Yeah, no, I don't have it connected here either. That's a bit strange. But in any case, on my Word document, I've said pin 3 from the Pico goes to ground of the servo motor, which is the brown cable. That's fine. That goes to ground there. And I've said pin 40 from the Pico goes to the VCC of the motor. So that's a red cable there. That works fine. And I said pin 23 of the Pi Pico goes to the signal of the motor, so the orange cable. So that's what I left out by accident. So I'm going to go back to my circuit diagram here. Did I have it open? Yep, pin 23 is going to go onto this one here. So all I have to do is say, oh, I think I know why I left it off, because this doesn't actually line up with the pins properly. So this is pin 20 down here. We know we have 40 pins on the Raspberry Pi Pico. It goes from 1 all the way down to 20 here, then 21 all the way up to 40. So I can say 20 is here, then this is going to be 21, 22, 23. Because that's what I said I've connected it to do, I might as well do this. Drag this onto there, connect it like so. And you know me, I like to have my circuits looking neat, so I'm going to do something like this. Let's see if that even looks okay. No, too far out. Ooh, I don't like that. All right, so let's try and do this then. And let's maybe do something like that, and maybe something like this. That looks a bit neater. And that's it, circuit's connected. So I'm going to change this to a red wire just because I want it to stand out. Change this to a black one because that should go to ground, and leave that one as blue. And that's it. So I'm going to screenshot this diagram again. Now, this is not something I'm going to keep showing in every single session I do, but just because I made a mistake in this one, I might as well go back and fix it. Delete that one, paste the new one. So this is my new circuit diagram. Right, I've gone over the pin connections. Now let's go over the code. So let me open the server motor code here. I have commented as much as I could. And again, this is something I found online and I just added the comments. I changed the code around to make it do what I wanted it to do. So I said from time import sleep. So import sleep so we can pause the program later on. So we can tell the Raspberry Pi, actually, keep doing the most recent thing you were doing, pause there and just keep working on that. I've imported pin and PWM. Pin gives me the functionality to use the pins, the GPIO pins, as inputs and outputs for the Raspberry Pi Pico. And what PWM does or means, pulse width modulation. So that tells one of the pins, let me go back to my pin layout thing, if I can find it. Some of these pins will have PWM on them. I think anyone that's green, so most of the GP pins can do it, are PWM enabled or capable pins. Pulse width modulation simply means tell the thing or tell the pin to turn on and off at a certain frequency. So pulsing, that's the frequency. The width is how wide it's going to pulse for. So it's going to be maybe on, off, on, off, on, off, on, off, or it could be on, off, on, off. So that's the width, and the modulation simply means it's going on and off, on and off, on and off again. So it's modulating, it's going up and down, back and forth. So that's why we have pulse width modulation. That's probably a nice way to explain it. Let me go back to my code. I'm saying the PWM that I'm going to be using is 14. So that's the pin I'm going to be using for my PWM. I set my PWM frequency to 50, so 50 hertz. That's very, very slow for the Raspberry Pi. Remember, the Raspberry Pi has two processors. It's a dual core system, and they run at roughly 133 megahertz, so that's million times per second. So me going at 50 times per second is nothing to a Raspberry Pi Pico. I say, well, I define a function called rotate, and I define one called rotate right and rotate left. Rotate right and left do more or less the same thing, but in opposite directions. So I say, for position in range 1000 to 9050, and the reason it starts from 1000, 1000 is the 0 degrees in a turn, so the location 0 essentially. 9000 is actually 180 degrees. So I put 950 because I'm telling it to step 50 each time. So it won't actually get to 9,000 if I don't say 9,050. It would get to 8,950 instead. But because I want it to get to the actual 180, I say 9050. So again, this is the starting point. This is the end point, and this is how much it should step each time. And I'm saying move through the duty cycle, so move to the location. So move to this specific location here. And remember, the Raspberry Pi Pico uses 16-bit values, hence why I put U16 here, and move to that specific position that I've put in here. I've also said print position because I actually physically wanted to see where it was at each time. Even though it would be very, very, very quick, I still wanted to see. This is like 1% of a second. Stupid fast, but still, I might as well see it. So that's the define function, so the rotate right function. Rotate left does exactly the same thing, but in the opposite direction. So rather than starting at 9050, I start at 9000. So that's my starting location. I go down to 1000. So again, 9000 is equivalent to 180 degrees. 1000 is equivalent to 0 degrees. Because I start at 9000 and I want to get to 1000, so I start at 180 degrees and I want to get to 0 degrees, I have to go backwards this time. So I have to minus 50. Instead of adding 50, I do minus 50. So I step negative 50 backwards. And just like before, PWM duty U16, I go to that specific position, the new position that's been given to me by this for loop here. And for every position I'm at now, I print the value of the position and I simply wait 1% of a second, so 0.01 second. Scroll down here, I have my infinite while loop. Again, an infinite while loop is decent for testing things because you want to see outputs, you want it to run forever. If this was not put in a while loop, this would run so quickly if I wasn't asking it to go again and again and again. I would have to use a for loop to be fair. So if I rotate right, well, the while loop says rotate right, and it says rotate left. So these are simply the functions I created earlier. I'm simply calling those functions or making use of those functions here. That's the only thing I'm doing in the while loop, nothing else. So I'm going to jump over to my breadboard now and show you what this actually looks like running. Here I am on my circuit. Now this is my server motor here. So I'm now simply going to press play on my screen and let's see what happens with the servo motor. It should just rotate back and forth, back and forth, back and forth. So press play. Now it's doing roughly 180 degrees, and again it's going between 0 and 180, pausing for half a second, I believe, or 0.1 second, then going back from 180 back down to 0. This keeps doing that forever and ever and ever because of this while loop here. Now the reason I'm printing on screen, I just wanted to make sure I was getting the values I was expecting. So again, between 1000 and 9000, then between 9000 and 1000. So that's the server motor there. Thanks for watching. Hopefully that was useful. I will put the code in either the description or on the website. Thank you.